Welcome to doassignment-ca. Here is the problem. A crate with a mass of 100 kilograms is subjected to two forces, an 800 Newton force directed 30 degrees below the horizontal, pushing to the right and downward, and a 1,000 Newton rope force directed at an angle whose slope components are 3 vertical and 4 horizontal. That is, at the arctangent of 3/4 above the horizontal, pulling to the right and upward. The crate starts from rest on a horizontal surface with a coefficient of kinetic friction mu sub k equal to 0.2. Determine the distance s the crate must slide to attain a speed of 6 meters per second. Now let us work through the solution step by step. First, let's break each applied force into horizontal and vertical components. The 800 Newton force acts 30 degrees below the horizontal, directed to the right and downward. Its horizontal component is positive 800 cosine 30 degrees, which equals positive 692.8 newtons, and its vertical component is negative 800 sine 30 degrees, which equals negative 400 newtons. The 1,000 Newton rope force has slope components of 3 vertical and 4 horizontal, giving a sine of 3/5 and a cosine of 4/5. Its horizontal component is 800 newtons to the right, and its vertical component is 600 newtons upward. Next, we find the normal force by summing forces in the vertical direction and setting the result equal to 0, since the crate remains on the surface. The weight is 100 times 9.81, which is 981 newtons downward. The 800 Newton force pushes the crate down by 400 newtons, and the rope pulls it up by 600 newtons. So the normal force equals 981 plus 400 minus 600, which is 781 newtons. The kinetic friction force equals the coefficient of kinetic friction times the normal force. That is 0.2 times 781, which gives 156.2 newtons. This friction force acts leftward, opposing the crate's rightward motion. Now we apply the work-energy principle. The net work done on the crate equals the change in kinetic energy. Since the crate starts from rest, the initial kinetic energy is 0. The final kinetic energy is 1/2 times 100 kilograms times 6 meters per second squared, which equals 1,800 joules. So the total net work done on the crate must equal 1,800 joules. Only horizontal force components do work as the crate slides to the right. The 800 Newton force contributes positive 692.8 times s joules. The rope contributes positive 800 times s joules. Friction contributes negative 156.2 times s joules. Weight and the normal force are perpendicular to motion and do no work. Adding these together gives a net work of 1,336 times s joules. Setting the net work equal to 1,800 joules and solving for s, we get s equals 1,800 divided by 336.6, which is approximately 1.35 meters. This is the distance the crate must slide to reach a speed of 6 meters per second. To summarize, the mass is 100 kilograms, the initial speed is 0, and the target speed is 6 meters per second. The normal force is 781 newtons, giving a friction force of 156.2 newtons. The net horizontal work per meter of travel is 336.6 joules per meter. Setting this equal to the required kinetic energy gain of 1,800 joules gives a sliding distance of approximately 1.35 meters. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.